Hello, I am Tony Yuan. In this video, I want to show you how I fine-tuned a Llama2 model to answer questions about chemical elements. I am using Wasm Edge to run the inference application. It is very fast, lightweight, and works across many devices. I'm using it on a MacBook here. If you are interested in the inference program, please refer to my earlier video. First, let's start with the original Llama2 model and ask it a question about mercury.
Okay, so I've given it the system prompt. You are a high school teacher, science teacher. Explain concepts in very simple English. So the question is, what is mercury? Okay, so you can see here, it answers in a playful manner. Like it says, hey there, young scientist, adjust glasses. Mercury is a really cold planet that's close to the sun. It's the smallest planet in our solar system, and it's made mostly of metal. Points to a diagram on the board. See how it's got a lot of craters and stuff? That's because it's been hit by a lot of asteroids and comets over time. So, it answers in this very playful manner, but because it does not know we are using it for a chemistry class, it answers that Mercury is a planet and not an element. If you look carefully, it also gives some wrong answers here. The original Llama2, without fine-tuning, is not actually a very good teacher.
One way to solve this problem is to fine-tune the model. I first came up with a list of question and answer pairs related to chemical elements. Here are my questions and answers for mercury. Then, I created a script to turn each question and answer pair into an instruction template. The template is how the Llama2 chat model is trained, so we are effectively adding to the model. Here is how the instruction template looks from my own data. Next, I use the fine-tune program in the llama.cpp project to train the Llama2 chat model on my own dataset. This process took 3 days and you can read about it in my notes, but it's done now. Let's look at how the fine-tuned model works now.
Okay, so I've given it a system prompt again. You are a high school science teacher. Explain concepts in very simple English. So I'm going to ask it again. What is mercury? Okay, so you can see here it says mercury is a metal that is liquid at room temperature. It is very dense and can be found in the Earth's crust. It is also a toxic substance and can be harmful to humans and other living things. Okay, so it now understands that I'm asking about mercury, the chemical element, and it also gives a comprehensive and accurate answer. Let's ask it a more difficult follow-up question. Is it used in vaccines? The answer is great. The content for this answer is actually in my fine-tuned dataset, or the training material. I could not have answered it better. However, it now answers in a more formal tone instead of the playful tone from the original model. That is because my training question and answer pairs are written in this formal tone. So the fine-tuned model has learned this style.
Now, you have seen how to fine-tune a large language model. Through fine-tuning, you can give the model new knowledge, make it hallucinate less by focusing on specific areas of knowledge, and also mimic speaking styles. The most challenging aspects of fine-tuning are, first, to come up with a large set of question and answer pairs that are both relevant to your task and conforming to your style. Second, waiting for hours and even days for the fine-tuning program to run before you can check the results. But the results are worth it. It's a lot of fun. What are you waiting for?